In the previous movie, we constructed the jetpack's fuel tanks, stabilizers, and thrusters from simple primitives. In this movie, we'll cover the remaining air intake and door panel components. Open the file jetpack-game-asset-part3-start.mlt, or continue using your own file from the previous lesson. Start by adding the two groups we created in the previous movie to a new layer named components_layer. Set its display type to template. Also, update each reference plane with the images included with the scene files available for download with this movie. Finally, in the Settings section of your preferences, make sure that your angular working units are set to degrees. The air intake object resembles a tapered cube, with a cavity on the top face and a slight extrusion on the front. Create a polygon cube like we did in Part 1, and position it in all views to match the reference images. Rotate it 25 degrees in the x-axis, and scale it 1.5 units in the x-axis. In the channel box, click the cube's shape node and set both the subdivision width and depth to 2, which gives you more vertices to start shaping the object. Open the Modeling Toolkit and activate it. Enable symmetry and then adjust the vertices to match the air intake's reference outlines. Remember that you can switch between world and object coordinate space in order to better control the vertices. To shape the top cavity, we'll extrude the top faces twice. The first extrusion defines the cavity's rim. Click Reset Settings, and then set Offset 2.15. Press Enter to confirm. The second extrusion creates the cavity itself. Reset the settings again, and then set Local Z to -0.5. To complete the air intake, create one more extrusion at the front of the object. However, instead of simply extruding these large faces, we'll break them in half by inserting a new edge loop with the Multi-Cut tool. In the front view, hold down the Control key to preview your edge loop insertion, and Control-click to insert a horizontal loop above the outlined shape. Insert a new vertical edge loop on each side of the outlined shape. Using the Multi-Cut tool again, create a 3-point cut to connect these two edges. Press Enter to confirm. Now connect these two vertices to convert this n-gon into two quad-sided faces. Once done, extrude the inside faces. Set Local Z 2.3. Adjust the new vertices to match the reference outlines. Don't forget to use transform constraints to slide vertices around without altering your object's shape. Here, we'll insert another edge loop to further define the shape and keep a uniform polygon distribution. Select all the bottom edges and create a rim using the Bevel tool. Since the jetpack will be frequently viewed from a top-down perspective, you can delete the bottom faces if you want. Next, let's jump to the jetpack's door panels that complete the body shell object we modeled in Part 1. Breaking their shapes down to primitives is a little bit trickier than previous components since they are essentially metal sheets bent on multiple axes. We could start with a cube and progressively extrude its faces until we reach the desired shape, but this could take some time and may not guarantee good topology or consistent thickness. Instead, we'll use a different technique and model these objects as if they were 2D planes using the Quad Draw tool. In the front view, click along the center panel's outline to create 24 vertices. At any time, you can reposition a vertex by middle dragging it, or remove it entirely with a control click. Hold Shift to preview the quad-faced polygons defined by your new vertices. You'll notice that we're missing a column of vertices to define the object's symmetry, so create 9 more vertices to split the panel in two. Shift-click to create consistent quad-faced polygons on both sides of the panel. To remove a face, Control-click it just like you did for vertices. Just be careful, as doing so also deletes the associated vertices. Don't worry if your faces aren't completely symmetrical at this point, as long as you have the same amount of vertices on each side of the panel. Select all the center vertices and scale them in the x-axis to align them. In the side view, move all the vertices along the z-axis to match the reference outline. Select a center edge and turn on symmetry. While we've been using symmetry up to this point to mirror our iterative modeling operations, we can also use it to copy one side of our mesh to the other. Select the vertices, edges, or faces that you want to mirror to. Then in the Modeling Toolkit, go to Edit, Symmetrize. My ALT mirrors the opposite side of your selection. To curve the panel in the z-axis, we'll first use the Multi-Cut tool in the front view to insert a new edge loop bordering the reference outlines. Remove the topmost edge with its corresponding vertex by pressing Ctrl-Delete. Convert the n-gons into quads like we did for the air intake. Move the outside edge loop in the side view to curve the panel's shape. Extrude the bottom edges to finish the shape. Since the panel is designed to open, we need to connect both sides using the Bridge tool. Set divisions to 1 to create the center edge necessary to bridge the top faces. Select the border edge loop and bevel it. Set offset to 0.5. Using the techniques we've seen so far, create the remaining cavity in the middle of the panel. Remember to keep a clean topology so that you can make these quick alterations to your mesh. The last object we'll create is the left side panel. In the front view, use the Quad Draw tool to create a new polygon strip following the center panel's topology. Then append a second layer strip covering the rest of the side panel. Adjust the new vertices in the side and top views to curve the panel until it matches the reference outlines. Progressively insert new edge loops using the multi-cut tool to further define the panel's shape. This panel is designed to go over the thruster as well as tuck into the fuel tank. However, it's a little hard to preview how their volumes match since all the other objects are in wireframe. Set both layers' display type to reference. This will give you a shaded view of them while keeping them locked. Extrude this bottom edge in the side view to complete the panel's shape around the main jetpack body. Now to add thickness to this object, go to Face Selection mode and double-click any face to select the shell. Click Extrude and set Local Z to -0.1. Select all the border edges and create a bevel with an offset of 0.5. Use the Target Weld tool to remove any leftover triangles. Select the air intake and door panel objects and delete their history. Rename them air_intake_geo, center_panel_geo, and left_panel_geo respectively. Create a mirrored duplicate of the left panel and rename it accordingly. Lastly, freeze all your object's transforms. In the next movie, we'll finalize our jetpack and create multiple levels of detail, or LODs.